Did you know that there are more possible chess games than there are atoms in the observable universe? And the number you see on the screen is the amount of possible chess games. As you might notice, this is a large number, and it's hard to wrap your head around the size of it. But one thing we can do to make this a bit easier is to write it as an exponentiation. In this case, we get 10 to the power of 123, which is 10 times 10 times 10, 123 times. In other words, a 1 with 123 zeros behind it. Next, we have another large number, which is an estimation of the amount of drops of water in the ocean. As we see, the number starts with 1332, and hence we cannot write this as an exponentiation on its own. So to do this, we need to introduce scientific notation, or standard form. In this case, we can write a comma behind the 1, and we get 1.332, and we can count the number of digits behind 1 to find the exponent of our exponentiation with 10 as base. This means we can write the number as 1.332 times 10 to the power of 18. And this is an example of scientific notation, or standard form. We have some number between 1 and 10 times an exponentiation with 10 as base. So we can use this to make large numbers more compact. Let's look at a few examples. 9 million can be written in the following way. We have 9 times 10 to the power of 6, and 10 to the power of 6 is the same as 1 million. In this case, we set a comma after the first number 1 and we get 1.2. We then count the number of digits behind the comma. In this case, we have 3 numbers, and therefore our exponent becomes 3. And remember that 10 to the power of 3 is the same as 1000. In other words, we have 1.2 thousandths. Here we have 93,000. You can now pause the video and try to write this number in scientific form. And the answer is 9.3 times 10 to the power of 4. Scientific form is not only applied to make numbers easier to read, but it can also be helpful when doing division or multiplication. Like in this case, we have 9 million times 300,000. So to multiply these numbers, we start by writing them in scientific form. And we get the following. Next, we sort the numbers, and we start by multiplying 9 and 3, and we get 27. And when multiplying exponentiations with the same base number, in this case 10, we need only to add the exponents together and we get the number we are looking for. In this case, we get 10 to the power of 6 plus 5, which is the same as 10 to the power of 11. So we get 27 times 10 to the power of 11. But as the keen viewer might have noticed, this is not a true scientific form. Since 27 is not a number between 1 and 10, so we need to rewrite 27 as 2.7 times 10. And we can multiply 10 and 10 to the power of 11 to get 10 to the power of 12. So we can conclude that 9 million times 300,000 is the same as 2.7 times 10 to the power of 12. Another application for scientific form or standard form is to write small numbers. Here we have 0.00000000001, which we can write using exponentiation. We get 10 to the power of minus 9, and according to the rules of exponents, this is the same as 1 over 10 to the power of 9. So 0.1 then equals 10 to the power of minus 1, which is the same as 1 over 10 to the power of 1. 0.01 then equals 10 to the power of minus 2, which is the same as 1 over 10 to the power of 2, and so on. Let's use this to write this number on standard form. First of all, we need to count how many times we move the comma. In this case, we move it 4 times. And this tells us the exponent of the exponentiation. We therefore get 2.45 times 10 to the power of minus 4. And we have written the number in standard form. If you found this video helpful, please like and subscribe.